Hi everyone, in today's video we are starting our Pandas for Data Analysis series where we are going to learn the Pandas library syntax by walking through a real-world exploratory data analysis. So in this first video we'll cover what Pandas is, how to install it, how to read in files, and how to do some basic data inspection. Now before we get into the Pandas library installation and code, I just wanted to quickly review what Pandas is and why we use it. So just bear with me for about 30 seconds here. Pandas is a Python library for data manipulation. It gives us a way to manipulate, clean, and analyze data. And it's used pretty extensively, so it's an important library to know, and it's not too hard to pick up. All right, so let's jump over to our Jupyter notebook here. So the first step when you're first working with Pandas is to install the Pandas library. Now, if you're running your code in Anaconda and that's where you're using your Jupyter notebook, you can skip this step because Pandas will already be installed for you. But if you're using VS Code and Python and pip like I am, you will have to run this command, pip install pandas. And what this does is this exclamation mark, also known as the bang operator, just tells Jupyter Notebook that you're trying to run something in command line. And then this right here is the command that you're running in command line. So pip install pandas will install pandas to your environment. And just so you know, if you want to install any Python library, this is how you do it. You do pip install and then you just specify the library name. So when I run this, I already actually have pandas installed. So you'll see that it just tells me that pandas is installed. But if you don't have it installed yet, it'll actually show you that it's installing. Now that we have pandas installed, the next step is to actually import the pandas library into our notebook so that we can use those functions. So to do that, we just need to type in import pandas as PD. And what this will do is it'll import all the pandas functions into our notebook, and we are going to use this PD to reference the functions from the pandas library. Next, since this is an exploratory data analysis project, we will load in our data set that we're going to analyze. And for this tutorial, I'm using this LinkedIn job postings data from Kaggle. It contains information about job postings directly from LinkedIn for the years of 2023 to 2024. So this is where you can find that data set, and I'll post a link to it in the description of this video as well. So you can just download this data set from Kaggle, and when you do that, make sure that the notebook where you're writing all your code is in the same directory as the data set as well. So here is the data set. You'll see there's a lot of different data files in it. Postings.csv is the one that we're mostly going to use, but we may use some of these other ones later on in the analysis as well. And here's that postings.csv in Excel. So you can see we have like the company name, we have the job title, we have like salary and all of that information about the job. All right, so to read in the data set, we are going to use Pandas read CSV function. So we'll create a variable called postings, and we'll set that equal to pd.readCSV. And to this function, we'll pass in postings.csv, which is this file right here. It's the one that I was showing you in Excel. All right, so to review this portion of the code real quick, we're using PD to call a function from the pandas library, in this case, read_CSV. And what that read_CSV function does is it takes a CSV file, it reads it in, stores it in a data frame, and saves that to the postings variable. So here we've given it postings.csv, which is the file that I had open here in Excel. And I will note, if your notebook is in a different directory than your CSV file, just make sure that you specify the relative path to the CSV file. So let's say postings was under this mappings folder instead of in our root folder. Here we would specify mapping/postings.csv. Now, Pandas can also read in different data types. It can read in JSON files. I believe it can even read in Excel files and Parquet files, and there's different functions for that. So it would be read_Excel or read_Parquet, read_JSON, and so on. All right, we will run this so that we will have our data frame saved to postings. So while this ran, Pandas opened postings.csv and it saved it to a data frame, which we can access using postings, and we can look at what is in postings using Pandas head method. So we do postings.head. And when we print this, we'll see what's stored in postings, and that is the data frame. You'll see it contains all the same columns that we had in this postings.csv file. And if I open that CSV file again, you'll see that the columns are in the same order as well, like job ID, company, title, description, and so on. They're in the same order here as well. So I've said the word data frame a few times without defining it now, and so let's pause here and go over what a data frame is. So this object, this postings object here, and what you see here is a Pandas data frame. A data frame is one of the main data structures in Pandas. It's a tabular data format that contains multiple columns, and each of those columns can be of a different data type. So you see here max salary is a float data type, but things like title and descriptions are string data types. You can kind of think of a data frame kind of like a worksheet in Excel. Now this data structure, this data frame also has an index, which you will see here. The index starts at 0, and it's just a series of labels that uniquely identifies each row. And it defaults to these numeric labels, but you can also set a column of the data frame to be the index as well. And this is something we'll cover more in future videos, but for now, that's just an introduction to the idea of an index in a data frame. Now, the other data structure in Pandas is a series, which is just one column from the data frame. So if we only selected job ID, that on its own would be a series. And since it's just one column, unlike a data frame, which can have multiple different data types, a series only has one data type, the data type of whatever the column is. And we'll look at what a series looks like a little bit later on in this video. Now, going back to this function up here, it defaults to show the first 5 rows of the data frame, but we can actually specify the number of rows we want to show. So we can even do something like 50, and then you see the first 50 rows of the data frame. But for now, we'll just keep it at its default of 5. Now you may notice you're seeing some of the columns here, and then you're seeing these ellipses and then the rest of the columns. That's because when you print out the data frame, if there's a lot of columns, Jupyter Notebook and Pandas kind of by default just truncates the columns. You can stop that from happening by specifying a specific setting. We can do pd.set option, and this helps you set a lot of display options for your data frame. So we're going to give it the parameter display max columns, and we're going to set that to none, which means we want to see all of the columns. So now when we do postings.head, you can see that ellipses is gone and that we can actually see all of the columns now in the data frame. So reading in the file and just making sure that the data frame looks okay, it matches how the actual data looks in the CSV is generally like the first step I do when I'm using Pandas to analyze data. And once I make sure everything looks okay, all the columns came over correctly, we're not missing any of the columns or anything like that, the next thing we can do is we can do some simple data inspection. This is some really light exploratory data analysis. And this is where we can look at the shape of the data types of each of the columns, and we can get some basic information of what data might be missing from our data set. And this step will really help us come up with questions that we want to ask and analyze about the data set, and it will also help inform us of any cleaning steps we need to perform on the data set before analysis as well. So let's start with the shape of the data set, and what that will tell us is how many rows and columns we have in the data set. So we'll take our postings data frame and we will do dot shape, and when we run this, we'll get 123,849 and 31. That means we have around 124,000 rows in the data set, and we have 31 columns in our data set. So now let's take a look at those 31 columns as well. We did see them up here when we were looking at the data frame, but sometimes it's easier to just see them as a list of values. So to do that, we can take postings again, and we'll use the dot columns attribute. And when we print that, we'll get a list of all of the columns in the data frame. So as I mentioned, we have things like company name, max salary, location, and we also have things like the listed times. So I like to use this attribute really just to see if there's any column names that stand out to me as ones I'd like to explore more. Like looking at these column names, one idea I have is that we could explore job postings by location or job postings by listing time. This is also a good way to get a quick view of if we want to rename any columns. For example, we know that title contains the job title because we saw that in the actual data frame. Like we see service technician, assistant restaurant manager, etc. So maybe that's something we kind of want to clean up when we're cleaning the data set. Maybe we want to call it job title to make it more descriptive. Now, in addition to just looking at all the columns that are in the data set, we can also get some more information of each of these columns by using the info function of Pandas as well. So to do that, we'll take postings.info and we'll run this and you'll see what it actually shows. Now, if you're in VS Code, you'll see that there's some truncation happening here as well. But if you click scrollable element, you'll see all the output that you need to see. So what postings.info does is it gives the name of each column. It gives you the count of the number of non-null rows. That means it gives you a count of the number of rows that actually have a value for that column. And then it also gives you the data type of that column. So there's a couple of use cases for this info function. The first is to just see if any of these columns have a lot of missing values. So let's look at job ID first. Here it's telling us that 123,849 rows have a value filled in for job ID. Now, if you remember, when we were looking at the shape, we have 123,849 rows in the data set. So if these two numbers match, that means that every row in the data set has a value for job ID. It is completely filled out. So when we look through this, we're really looking for any column that has a low number of rows with the value filled in. So things like median salary only has around 6,000 rows filled in, which is a fairly small percentage of, almost 124,000 rows. There's also things like close time only has 1,000 rows filled out. Skills descending also has only about 2,400 rows filled out. So this kind of informs us that these columns may not be super useful to our analysis unless we can find a way to fill them in. And if we can't, we might just need to drop them from the data set in our cleaning step. Now, the second use case of info is to look at the D types of the columns. A very common thing you'll see is that a column might have an unexpected data type. So for job ID, we would probably expect that to be an integer because it's probably just a number value. Company name, we would expect that to be an object, which really means it's a string data type. What is sometimes like a common issue is something that's supposed to be a numeric value, so like something like max salary. Here it is entered as a float variable, which is correct, but sometimes you'll see that come in as an object or like a string. And in our cleaning step, we would need to convert that to a float. Now, another way you can see the D types of each of the columns is by doing postings.dtypes. This will give you each of the columns and their data types as well. So that's another way you can get to the data types of each of the columns. All right, so next, let's look at what the columns contain at a high level, and then we'll look at some of the columns individually more closely. So first, let's look at the describe function from Pandas. So the describe function will give us some basic summary statistics about the numeric columns that we have in the data set. So we can do postings.describe, and when we run that, you'll see we have all the numeric columns, and in that we get a count of the number of values that we have. We get the average value of all the values that are there for that column. We get the standard deviation, we get the minimum value, and we get the maximum value, and then we get the quartile values as well. So here you can see for applies, you can see in the data set, the average number of applications per job is around 10 or 11 applications. You can see that the max number of applications is almost 1,000 applications. So that could be true. That might be something like we would have to investigate if we were going to use this column in our analysis. So that's just something to flag there. That gives you like a nice overview of the summary statistics for each of the numeric columns. For things like IDs, you don't really need this, but for max salary, views, median salary, it's pretty good to have this view. Now let's go over how we can select specific columns of the data frame and find out information about those columns specifically. So there's two different ways to select columns. One is by using square brackets. So if we take postings, and let's say we want to select the title column, we would type in 2 square brackets, and inside the square brackets, in a string, we would type in the name of the column, which is title. Now, when we print this, we will get a view of that column. Now, this is the series that I mentioned earlier. It's just one column, and you can see the data type is just object or string. And that's the only data type in the series because this is just one column, so it only has one data type. Like I mentioned earlier, you can think of a data frame kind of as a worksheet in Excel. Well, you can think of a series as just one column in Excel. Now, this is probably a common way you're going to see columns be selected from the data frame, but the other way you'll see it is by using dot notation. So that would be doing postings dot title. So here you would just specify the name of the column. And when we print that, you see you get the same thing. You're still selecting title. Now, between the two of these, this is probably the better way in most cases to select a column, because for this one, you have to make sure that the column name follows Python naming conventions, which means like it can't have spaces in the name or anything like that. So if your column names have spaces, this is the better way to select the column. Now we can also select multiple columns, and we do that by basically just adding a list of the columns we want to select in between these square brackets. So we can take postings, and we'll do our square brackets again, and inside those square brackets we will specify a list, and let's say we want to select job ID, title, and description. So when we print this, you'll see we'll just get that subset of the columns. Now, one common use case for this is we'll actually filter down the data to just these columns and store that in its own data frame. So we can do postings filtered and set that equal to this selection of columns. And when we print postings.filtered, you'll see that this is a data frame that just contains the columns that we selected. So when we select singular columns, there are some functions we can run on those columns to get information about what values those columns contain and at what frequency. So for our analysis, let's say we wanted to visualize the number of job postings for each job title that we have in the data set. Well, this will only really be an effective data visualization if there's not too many unique job title values. So one thing we'd want to check is how many unique values are there for job title. So we can do that by selecting the titles column, and on that we can do .unique. So we're running the unique function on just the title column. So this will return all the unique values that are available in title. Now this does get truncated here a bit, but this will give us the shape of the list, which will tell us how many unique values we have. So here we have about a little over 72,000 unique values. So if you think about visualizing the number of job postings by job title, that means we'd have 72,000 bars on a bar chart that shows that. And that type of visualization is not something that's super helpful to us. So now, because we did this step, we know that we cannot visualize every single job title that's listed here. So one thing we could do is we could see what are the most commonly occurring job titles and maybe just analyze the job postings for the top 10 job titles. Well, to do that, we would do postings at title, and there's a function called value counts, which will count the number of times each title appears in the title column. So when we print that, we see things like sales manager appears 673 times, customer service representative appears 373 times, and so on. You'll also see that value counts automatically orders the result of this by whichever value appears the most. So sales manager appears the most, so it appears at the top. There's also other functions we can run on the columns themselves. Now, an example of this would be like a min and max function. So let's say we wanted to see the minimum and maximum salary. And I know we saw this in the describe function, but we can also do it this way. We can select max salary and we can find the minimum one. So here we can see that the minimum value is 1. If we change it to max, You'll see the maximum value is 120 million. That might also be something. We'd also have to look at that to see if that's an outlier or erroneous data, or if there is a job paying $120 million, which I guess there could be, but that would be something we'd have to check out as well. And you may be wondering why it's printing like np.float and then the value. We can get it to just print the value by enclosing this in a print statement. And you'll see we just get the number. That's kind of a nuance of printing this value in a Jupyter Notebook environment. All right, so I think that brings us kind of to the end of our initial data inspection. We have an idea of what the data set contains. We know some initial cleaning steps we may need to do. And I think we're at a point where we can start to ask questions about the data. Now, I know earlier I mentioned that one interesting analysis would be job postings by job title, and maybe we could just use the top job titles. But as I was looking at the data, I think something that would be even more interesting, especially for the audience of this video, is looking at job postings specifically for data professions. So like data analysts, data scientists, and all of that. So we can kind of come up with some questions that we want to analyze, which we will continue to analyze in future videos. So one of them is how many full-time data jobs are being posted by month. Since we have listing time, we can also ask which weekday seems to have the most number of job postings. So we can see, I don't know, like maybe more jobs are posted on Mondays or Tuesdays, or I think that would be something interesting to see. We can also do something with the salary. We can say what is the yearly salary distribution for full-time data roles. Since we have the locations of the jobs, we could also see which city has the most data job postings, city or cities. And as a final question, we could also see which industry is hiring the most for data jobs. Is it, is it tech? Is it healthcare? All right, so those are the questions initially that I want to ask about the data set, and it's the ones that we'll analyze in future videos. But this is the end of this video. I really just wanted to give you an introduction to Pandas and show you how to install Pandas, how to import it, how to read in the data set, and kind of how to work with the columns in the data set. In the next video, we are going to cover data cleaning and filtering of the data. We'll cover things like dropping values. We'll cover more about the index as well. So stay tuned for that one. Thank you so much for watching this video. I really hope it was helpful to you. If it was, I would love it if you considered subscribing to the channel and liking and sharing the video. It really helps. Thanks again for watching, and I hope to see you in the next part of our Pandas for Data Analysis series. See you there.